Today we're going to be learning how to grow trees on a spline. We want to grow trees just by doing this, and we want those trees to have branches, we want them to have sub branches, and we want them to have, let's say, leaves. So anyways, while this does not look at all like a tree, we will try to make a tree in Blender. So we have a couple of goals in this tutorial. First is we want to make the tree, and the second is we want to unwrap UVs, and the third we want to shade it. And while it's gonna be a long setup for anyone who wants to follow this, but my attempt is to do the effort once so that next time you can just import this as an asset.
So let us get started. We're gonna add a bezier and we're gonna rotate it along the X 90 degrees, and we're gonna apply that rotation. Let's just jump into geometry nodes. So let us take something new, call it procedural tree. So let's just do some housekeeping while we're at it. Since we're not getting a geometry right now, we're just getting a curve. So we will rename the input, and the output, we're going to be adding a curve to mesh node here. Let's connect another node, which is called curve spiral. We can set the start and end to 1 meter and the height to 0. Let's edit the spline to make it look more like a tree. So I'm going to take this here, and I'm going to move this up, and I'm going to do the same to this one, bring it to the center. The problem is right now that it's the same radius everywhere. We want it to have a different radius when it's thicker at the bottom and a different radius where it's thinner at the top. So we'll get a set radius node. If we change this again, the whole thing is getting affected. But what we will do is bring a node called spline parameter. What this does is that it stores the values of points on this spline from 0 at the bottom to 1 at the top, and it gives different radius if we give this factor to the radius. So we want to be able to control this radius from outside. So first thing we're going to throw out is a map range. Now this one is going to control the radius. So the 2 radius is the top. So let's connect this one here, call it start radius, and let's connect this one here and call it end radius. And we want it reverse right now. Why? Because when we draw the curves later on, our start and our end, right? Curve start and curve end. So select this spine and switch direction. So now when we've reversed it, our start radius is the bottom. So the bottom one becomes thicker and the end one becomes smaller. And now if we draw random curves, we get the right tree. So this is how we want it to be. It's too thick, so I think 0.3 is good. Cool. So we have the start radius, we have the end radius. We also want some more controls over here. We want to see the resolution of the cross section, this resolution. So because 32 is too much, we don't want that much geometry. So we're going to call it cross section. We can set this to 8 for the sake of longevity, because we want to use this as an asset. Let's just see what is the size of our item right now. It's 2.98 meters, right? So I want to make this taller. I'm going to select this one and just scale it up. The spiral radius really doesn't matter, but what does matter is that this be reverse, because that is when it packs. So make it reverse. Now we also want the resolution going from bottom to top. So we're going to need a resample curve node, and we will resample based on length. If we go up, the resolution increases. If we go down, the resolution decreases. So we will connect this to also to the inputs, and we will call this one length resolution. So we have a decent setup for our base tree geometry. Testing. If we just go to the spline draw and we draw a spline, we're getting it. We can do all sort of weird shapes, and cool. As you can see, if you notice here, this thing that is happening This is because the mesh is wrapping around itself. So to avoid that, we need to reduce the rotations and we need to make it almost one full rotation. So 0.9999, and now you can see that we don't have that. We want to output this curve as it is, right? Because this spline is what we will use, this geometry green input is what we will use to instance branches. And now we can group this and call it solidify. Do something here that we can call it bark. This is our bark. Let's introduce a trim curve because we would want to have the option to grow the spline, and this is how we will try to do that. So let's just keep it here for now. So let's go into instancing. So first instance on points, and if we say use a join geometry here, not strings. And right now we don't see anything, but let's connect a quadratic bezier which has a lot more control. So right now, as you can see, there is only two splines here on the main, the top and the bottom. So we want to resample this, and we want to resample it based on the length, and again the same logic. The more you go, the more, less branches, more branches. So let's keep it at 0.35 maybe. So yeah, we have this. Now we need to again throw in some inputs here. So let's plug in this one, which is the number of branches. So we need to make the start of our quadratic brazier 0. So now we can see that they are here. The middle y can be 0, z can be 0.5, and this z can be 1. This is 0. So now everything pointing upwards, right? And which is fine. Okay, so now we need to take care of the branch rotation, and we want to align this. Align Euler to vector. So I think x is the correct angle. I think z gives up, y gives that side. So it's either x or y. Let's just go with x. Here we can give a vector rotate, not a vector rotate. And we want to rotate around a certain axis. What axis is that? And that axis is the curve tangent axis. So tangent is simple. If this is a curve, this is its tangent. Tangent is a line that only touches a curve once, and this is the curve's normal. This is our curve. So we want to rotate around the tangent, and the vector that we want to rotate is the normal. Okay, let's try with a random value. Yeah, this is better. So the minimum is 0 and the maximum is tau. Tau is 2 times pi. So as we can see, nothing happens really. If we plug this here, then we get a bunch of random rotation, and if we put this here, we do get rotation, but it's not happening everywhere. That is because probably I'm aligning to only one vector. Maybe we can try to align to one more vector. I think we can align to y, because we know that y is one of the angles that are perpendicular to our tree. We can just group this and call it branch rotation, and we can bring it here. For the scale also, we will want to have some control, so we can give a factor float map range scale to this. Now to give it some thickness, we'll just reuse this and solidification, and we will do this. The cross-section resolution can be the same as this one. Let's deal with the radius. Let's take this to here, call it level 1 start radius, and let's take this one and call it level 1 end radius. And now start radius can be bigger and the end radius has to come down to like 0.01 or something. Now one problem here is that the start radius and the end radius are not dependent upon the spline parameter here. What we want is that if the branches are closer to the bottom, the base, then they should be thicker, and as it gets to the top, the branches can be thinner. So we already have a parameter for this in our level 1 bark solidification. What we can do is we can throw the radius out somehow, and how we will do is that we will take this and we will capture an attribute, and this we will plug as the radius. So we are capturing radius, which is a float point value, and let's plug this here, and let's call it the spline radius. So that should tell us what it is, and the minimum radius can be a factor of the spline radius. So let's bring in here and let's set a multiply node, and let's plug this into the minimum. Oh, sorry, let's plug this into the maximum, to which we can assign any value. Right now it's 0.5, and we attach it to 2 minimum. And we want to give it a default value of 0.5 and the minimum value of 0.1 and the maximum value of let's say 8. Let's select all of this, put it into a group, call it level 1, and here let's just rename some things that we have the outputs that are coming in. The first one is number of branches. The second one is the level 1 spline. This one is, I think we called it spline radius here, so we'll call it level 1 spline radius. And the last one is the level 2 spline radius. Actually, this is the bark spline radius. The first one is the bark spline radius, and level 2, level 1 spline radius. All right. So we have this. This is the first level of our branches, and I'm grouping it so that it is easier to reproduce. This is not how I usually work. I like to have my node graphs spread out. I will just show you a different model that I've already made of this, and so this is how it looks. This is how I like to work, but for the sake of the tutorial, I'm grouping things up. Just as a teaser, by the end of it, this is how many outputs we're going to have, this is how it's going to look, and this is how it's going to be shaded. Anyways, let's get back to the file that I'm creating for the tutorial. We have the level 1 branches. Now the problem is that the level 1 branches do not look like branches right now. And why is that? Because they don't have the length. We want them to be longer, and B, they don't have any characteristic geometry. So to give them the characteristic geometry, we will have to play with the middle and the end points of our quadratic Bezier. And to give it a scale, we would have to play with these numbers. So let's just see what these numbers do. If we increase the minimum to a crazy amount, nothing happens. If we increase the maximum, we get the length. So let's give this to an output, call it level 1 branch length. Let's increase the length a little. Right, and again the problem right now is that level 1 length is not obeying our spline. Spline. So if we look at it from the Z, you see all of them are scaled equally, right? And that's again not how it happens in the tree. The bottom ones have more length, sorry, and the top ones have less. So again, we're going to be introducing a multiply, a math node multiply, and I think we can probably multiply with this. No, let's try to multiply with the spline parameter only. Okay, so right now, as you can see, the bottom ones are shorter and the top ones are longer, and that is not the behavior we want. So we want the opposite of this. We want the lower ones to be taller, and as it goes up, the branch length decreases. Let's take a ramp and let's reverse the color ramp. So this is when we have reversed our curve. So right now you can see that these are longer and the other ones are shorter. Group this for the tutorial and call it scaling, because we can reuse this in level 2. These nodes, rotation, scaling, these nodes are all saved. Now we want to control the bending of these. Trees have all sorts of bendy stuff. So how we can do that is, like I said, by quadratic Bezier. So we have a middle. Let's just see what these points does. We are interested in the X movement. We're not interested in the Y movement, and the Z also gives us some control. Alright, bring this out to a combine XYZ, and now this one, X is interesting, Y again is a rotation, and Z is probably better set to 1. I think we want to have a combine XYZ again. We wanted to give the Y to 0, so let's just set a value of 0 to Y. Give it the same to this one. Take it here, take a math node, add number 1 and give it to the Z. Now we have the non-changing values pretty much set here. Let's bring a separate XYZ because we want to be able to control these points by these vectors, right? So X controls the X, Y controls the Z, and Z can control the X here. So now if I give some geometry to these things, some changes in numbers, you can see that we are getting some interesting shapes. I think I like it at 0.2. Let's give this here. This is an output. We can call it branch structure. We can group these because we might need to reuse them. Let's do something with selection over here because we have these from the ground. So what we want to do is pick up from the starting point and the ended point. So it's again going to be a spline parameter based boolean. So what we want to do is compare the points where this is being spawned. It's going to be an index based selection, and we're going to compare greater than or equal to, and then another, wait, let's just do a math compare actually instead of this. So we get greater than, and then we get a less than. Plug this here, and we then again use this to create a multiply node, and so multiply this and this. Now if we, so it's like pulling them out. This is the pull up. We give this one as a bottom distance. If we come out, let's output this vector, then let's output the top distance, then let's output the bottom distance. If I go here and group this and call this branch selection, and I'm happy with the branches, except we need to do one more thing, which is that the branches are never this nicely done, right? So now we go back into our level 1 branches and we want to add some noise here, and that noise will help us displace them because the leaves are like the branches are usually zigzag randomly. We're going to achieve that by a bunch of different things. The first of which is a set position, which is going to go here. So now we have all this space for noise. So what is noise? Well, noise gives us values from 0 to 1 for each point. So we go to noise texture, we go to 4D. Let's just plug the color here. So as you can see, everything is offset. So why is it offset? Because like I said, to every point, it is offsetting from 0 to 1. So what we need to do is subtract some value from it to have the points back at their positions. So you need to subtract 0.5 from everything. And now you can see that the noise is there, right? But it is still affecting everything, and we don't want it to affect our branch at the start. We want it to affect the branch at the end. Like if a branch starts from here to here, we want 0 here and we want 1 here. To do that is multiply this with our trusty spline parameter, and if we do that, you can see even if we increase the noise is limited to the edges. Let's just make it 5, and detail can be 0, roughness can be 0, and distortion can be, I think 0 is fine. We need to have a boost value for this. To boost the noise, you want to use another multiplier. So what I'm thinking is that we could boost it with a factor, because I don't want to send out like 3 like a vector output. So let's just introduce a math here, not vector math, just normal basic math. Let's multiply this by 1, and then if we boost this, we can see how much the boost is going, right? We want to output this, which is the noise wiggle. We're going to use this in animation. We want to output the noise scale. Detail, roughness, distortion is fine. And the last value we need to send there is boost. So we're not going to group this because we're not going to reuse this. So now it does look like a tree. So now we just have to connect these inputs to our main inputs, and we have everything here. Cool. So we do have a tree now, and again testing, we go into edit mode and start drawing, and we have a good tree. And this one did not have any points for some reason. I'm not sure what happened. Like for example, if we build from here, we have the branches. If we again build from here, we don't have the branches right now, because for some reason we are above the threshold. But if we change the top distance, yeah, you see this. This is going to depend on how you do it. And what I suggest is that for every tree, you make a different spline, right? You just copy it, make one more, and set it up quickly, and you're good to go. Or you can, just like I would somewhere we would get a seed distribution. We can just play with that, and probably that would give us we haven't output a distribution. Yeah, rotation should have a random value. Yeah, so this seed we can input. So this is distribution. This distribution can be again given to the output over here. I need to again output it here. Yeah. So this is where we end the first chapter, and in the next chapter we're going to be looking at how to make the second level of branches, how to do the instancing of leaves, and how to add the UV mapping with the new Blender 3.3 geometry nodes and the shading. So see you in the next chapter.